Hey there, chapter 4, section 1,
Which is a new chapter.
all about trig, and I love trig a lot, actually.
I do too. It's good times. So
Yes.
we're going to start off real simply with just angles and their measures.
That sounds excellent.
So the first thing we need to know, there are two different units we use to measure angles: degrees and radians. So a degree should be familiar to you because that's what you used in geometry back in the day. So an acorn, what does an acorn say when it grows up?
Gee, I'm a tree.
Yes! Okay. So a degree is a unit of measure represented by this little symbol, which we know as the degree symbol.
The degree symbol, like how hot it is outside, or cold, as it were.
Or when you're talking about angles. 1 degree is 1/360th of a circle. So back in the day, these people decided what a degree was, and they decided, hey, if we have a circle, let's divide it into 360 parts, and let's call that a degree.
Smarter people than us.
Yes.
Figure that out.
I don't know about smarter. Different people than us. Because to me, it would have made more sense to do like some other number than
Like
360. Like 1, yeah.
No. You were on a circle one time, you went 1 degree.
Yeah, that would actually kind of make sense. Mm-hmm. But they didn't ask us.
Okay.
A similar system called DMS, which stands for degree, minute, second, goes a little further. Like with regular degree mode, you can end up with things like, 37.9 degrees. But in degrees, minutes, seconds, in that mode, they take whatever the decimal part is and they keep dividing it into minutes and seconds. And so that's like when we have hours, minutes, and seconds.
Right.
It's pretty
exactly
equivalent
the
to that.
same sort of setup.
Because a minute is 1/60th of a degree, and a second is, should that be 3,600?
I think there should be one more zero.
There should be. This should be 3600.
And you primarily run into degrees, minutes, seconds when you're dealing with navigation, usually, but not always.
Yeah, we'll see it though throughout sprinkled throughout. Then this other thing that you probably haven't seen as much called a radian is a unit of measure where pi radians is equal to a straight angle. A straight angle, remember, is a 180-degree angle, and so we would say that to go from here to here on this, that would be pi radians.
Right.
So,
and radians is where we will live primarily. We will take small short vacations to degree land, but it's time to put on the big kid britches.
And start using radians.
We're going to use radians. And oh, by the way, we're going to use radians without decimals, so that's even more big kid britches.
Right.
But that's coming. That's where we're headed. So,
so
this is a pretty important concept, radians.
Yeah, it really is. So let's dig in. So, example 1, working with DMS measure. We want to look at how to convert from degrees, which sometimes they call this decimal degrees because we have a decimal here. So from degrees to DMS, and then we'll try DMS, which is right here, to regular degrees. So for part A, we have 37.425 degrees. And so in degrees, minutes, seconds, that 37...
425.
Oh, sorry. That's terrible. Why would I try to write over it?
Just like one of the kids.
Hey now.
Hey now. Okay, so what you're going to do is you're going to keep the 37, that's the actual degree part, and then you're going to take the 425 and we're going to convert it. And in order to convert, we're going to multiply it by 60 minutes.
There's 60 minutes in 1 degree.
Yep.
So we've got a little conversion thing going on here.
Just like right out of the alchemy classes. So when you do that...
chemistry.
Right. You said that, not me. So 25.25 is what we get. So
25.5.
25.5. That's what I said.
Minutes.
Right.
But we just take this whole number part, the 25.
The integer part. There's your minutes. And then to get seconds, we're going to take 0.5 times 60 again.
Because we're already in minutes.
We're already in minutes.
So there's 60 seconds and 1 minute.
Right. And it's 30.
Okay.
Works out perfect. How amazing is that?
It's almost like it was planned. So these marks, by the way, we just called these marks minute and second. They look like feet and inches, but apparently we double dip with this notation. So keep that in mind, minutes and seconds. So if you take the decimal part, times it by 60, and that gives you the minutes, take the decimal part and times it by 60 again, and that gives you the seconds. So this is our answer for that one. Okay, and then part B. We want to go from degrees, minutes, seconds to just regular degrees. So what we do is we take...
We're going to do the opposite of multiply first off, once we get going.
Right. So,
after we write down the problem.
So basically, if we take 24 minutes and we put it over 60 minutes, that's going to give us how many degrees it is.
24 over 60?
Yeah.
I feel like that's correct.
And then whenever we do 36, how many seconds are in 1 degree?
36 times 36. 60 times 60.
Right, and
yes.
we're adding all of these together.
Right. So 42 degrees plus 0.4, that's your minutes action.
Okay, the minutes is telling you 0.4, so 42 degrees plus 0.4
0.01
plus 0.01 from that last part. So that should be 42.41 degrees.
Yeah, not hard.
No. So it's just opposite. This way you're going to multiply the decimal part and then multiply the decimal part. This way you're going to divide by how many minutes there are, how many seconds there are.
Love it. One of the most important things that you are going to have to work around as you're learning to use radians and degrees is converting between the two.
Right, because sometimes you may find it easier to use degrees, but if we want the answer in radians, then what are you going to do? You're going to have to convert.
You're going to have limited time at some point, and you won't have time to convert back and forth all the time. So we've got to be able to have a good grasp of how these two things are related.
So the conversion rate is that 180 degrees equals pi radians, which at the very beginning we showed that straight angle, 180 degrees, we said that was pi. So that's where this comes from. 180 degrees equals pi radians. And normally we don't write the radians down necessarily.
Hardly ever.
Yeah, but that means that either we're going to end up having to multiply something by pi over 180 degrees, and that would be if we were converting degrees to radians, because it'll cancel the degrees out.
Right.
Or we might have to multiply by 180 degrees over pi, and that will cancel
the radians out.
Right, which is and give you degrees.
Right.
So here is our example. So part A, how many radians are in 90 degrees? So if we take 90 degrees, that's correct. 90 degrees. We want to cancel the degrees out, so we'd pick this fraction, pi over 180.
Cancels out the degrees when you do that.
It does indeed cancel out your degrees. The other thing it does is we need to, like you could write this as 90 pi over 180, but then we need to simplify that fraction. 90 over 180, that's 1/2. So that's pi over 2.
That's what I said.
I know you did. Congratulations.
Thank you.
Basically, when you're simplifying this, like if it's something more difficult to work out than this, you can take everything but the pi and stick it in your calculator and simplify the fraction if you need to, and then put the pi back on top.
A lot of times we're going to ask that you leave pi in your answer. So if you come up with some goofy decimal like 3.71829 pi, you're going to reject that.
Right, and this is the same if you type this in to your calculator as like 1.68. I don't know, 1 point something. We don't want that. We want 1.570779. We don't want that. We want pi over 2. So make sure you leave it like that. Now part B. How many degrees are in pi over 3 radians? So we start with pi over 3. We want it to be in degrees, so we want to multiply it by the one that has degrees on top. So 180 degrees over pi. The other thing that happens is that our pi will cancel out.
No more pi.
No more pi.
Bye-bye pi.
So we get 180 degrees divided by 3, which we can figure that out pretty easily.
By the way, you can reduce 180 over 3. Don't let it just sit there looking awkward.
Yeah, it is 60 degrees.
Hey, so we're going to talk about something that you use trig a lot for, which is bearing.
Right. Course or in navigation, the course or bearing, which we're going to see this word a lot, of an object is the line of travel measured clockwise from due north. So look, here's a compass.
That's a magnificent compass.
Thank you so much.
Did you draw that by hand?
No, I didn't. I took it from somewhere. This up here at the top is 0 degrees. And also in navigation, we usually do use degrees, minutes, seconds. So up here at the top is 0 degrees. Then we measure clockwise from north. Okay, and this is going to be backwards from the way we actually do it most of the time in trig. So if we start at 0 degrees and then go this direction, then that puts 90 degrees here, because 90 degrees is a right angle. And then you keep going.
180 is due south.
Right. And then over here at west will be 270. And I just added 90 each time to get these.
Mm-hmm.
Now, and the problems in the books related to this, they have a compass there, and then they ask you, like, at what degree is, northeast or northeast or whatever. So that if we know that 90 degrees is here, what's halfway between 0 and 90? What degree?
45.
45. What's halfway between 45 and 0?
22 and a half.
22 and a half, and so on and so forth. So you can find all of those degrees around. The other thing that will come up at some point maybe is that apparently there's these things called nautical miles.
I don't know. Maybe it has to do with nauticals.
Which is a sea term, like when you're out in the ocean. So in case...
What's in the ocean?
In case it comes up, 1 normal mile, which is apparently a statute mile, 1 normal mile is approximately 0.87 nautical miles. 1 nautical mile is approximately 1.15 statute miles.
This is like going between kilometers and miles. It's just a little conversion trick. And again, it's not going to be something that we're going to use a whole lot, but it is something that comes up when you're talking about navigation.
And now you know how to do that.
There's
if you see
conversion.
That. Circular arc length. Looking at how to measure pieces of a circle, I guess?
Yes, the arc of a circle, that's like part of your circle. Look, here we have a circle.
Like a pizza crust.
Like the pizza crust of a pizza. So what's going to happen is they're going to give us some information about a circle. And so, like, maybe they have this piece cut out of the circle. So we've got this angle right here, which we call theta. That 0 with a little loop, that's a theta.
It's on your calculator, too.
Yeah. Yeah, so that's a theta. And then S in these formulas is the length of the circle from where that angle starts to where it ends.
The intercepted arc?
The intercepted arc, you might say, yes. And then R, we know that one, that's the radius. So that's all of our things in both of these formulas. That's all of our variables. So the reason we have 2 formulas is if they give us the angle in radian measure, our formula here is a lot simpler. The arc length equals R times theta, the radius times the angle. But if they give it to us in degree, we have this more complicated formula, because basically inside of this we're converting from degree to radian,
right? Because
that's so much easier to use instead of having to, instead of trying to come up with a different formula for degrees, I guess.
Right. Because the formula is designed to work with radians.
Yeah, it's a lot easier that way.
Right.
So let's, what do you say we do the examples?
Okay, let's do
related to this.
Sure.
Okay, so look, we've got our formulas up here at the top that I re-put, and keep in mind you have a whole extra slide there at the bottom of your page to write this out. You don't have to try to fit it all like on the previous slide, because there wasn't a lot of room. So we are trying to find the missing information given what they gave us. So like
it's basically
in A,
going to boil down to how good are you with some algebra.
Right, yeah. So in A, we're looking for S. We know the radius and we know the angle. And what's important here is that our angle is in radians. So we have to use this first formula because our angle is in radians. So we don't know what S is. Our R is 1 and our theta is 70. So 1 times 70 is...
70?
70.
Hold on, let me get my calculator.
And then that's in centimeters because we're talking about the length of our arc.
70.
70 centimeters, okay? So that's part A. That was pretty easy.
Hey, that's not bad at all.
How about B? We are looking for S. We have R and we have theta, but now theta is in degrees.
Got to do a little conversion action.
So, well, yeah, we have to either convert ourselves or we use this formula. So,
but you're converting inside the formula.
Right, so we might as well use the formula.
Way.
But if you say forgot the formula.
If you forgot the formula.
So the radius is 5 and the theta is 18.
All over 180.
All over 180.
Now, just get used to leaving pi in your answers on these things. We don't want, if there's a pi involved, we will not be grading anything with a decimal in it. Just Just so you know.
Even for arc length?
Maybe for arc length, but maybe. But we like to see pies a lot, too.
Yeah.
That's an exact answer.
So if you're leaving pi in your answer, if you're writing it in terms of pi, you might say, you do 5 times 18 on top.
90.
So that's 90 pi over 180. And if you simplify that, 90 over 180 is a half, so that's pi over 2. And that's in feet, because our radius was in feet.
Right. Now, if you really want to know a decimal answer for that.
So that 1.57?
1.5708.
But we're fine with that pi over 2 as an answer.
Pi over 2 this is a perfect time to start getting comfortable with pi over 2.
Yeah. Part C. Now we know S, we know R, we're looking for theta. So here is the question, which formula are we going to use? Because it doesn't tell us if theta is in radians or degrees.
I say use the first one.
Because it's easier?
Yes.
So if they don't specify if they want our angle in degrees or radians, then we can just choose to make it be radians, because radians are better anyway. So we have 4 inches equals 7 inches times theta. So to solve for theta, we divide by 7 on each side, and we get 4 over 7. That's in radians, so we could put radians or RAD after it, but just know if we have an angle and we don't put any type of unit, we are assuming that that means we're in radians.
Yes, every time.
Yeah, so that was angle measure, circular,
arc length.
Arc length.
So the concentric circles on an archery target are 6 inches apart, and the inner circle has a perimeter of 37.7 inches. What is the perimeter of the next largest circle?
Now, when we're talking about circles, the perimeter has another name. What do we call the perimeter of circles?
Circumference.
Circumference. Okay.
Oh, that's going to drive the OCD kids crazy.
That I took away part of it.
If you are one of those OCD kids, pay no attention to the random dots. Oh, we should have left them. Or the fact that the red circle is missing a piece and the purple circles. Don't look at that if you're OCD. Focus on something else.
Yes. So we've got this archery range thing going on here, and we know that the circles are 6 inches apart. So this part of our line right here is 6 inches. Because they're 6 inches apart.
Right.
What else do we know?
We know the inner circle has a perimeter of 37.7 inches, or
Circumference
of 37.7 inches. So throw back to your geometry days.
Now, circumference equals 2 pi r.
2 pi r, yes.
So if the perimeter of the smaller circle is 3.7, can we find the radius from that? I believe we can.
And in this case, it's
okay to get a decimal answer, actually.
Yeah, because they gave us a decimal, and it's a word problem. And in general word problems, we would rather have decimals.
I got 6.
Point 000.
So not 6 exactly, but 3 decimal
places. Pretty close to 6. So not only is this one 6, but this one is also 6. This radius inside of here. We want the perimeter of the next largest circle, and that the whole circle here also has a circumference of 2 pi r. But now we know that the radius is 12. So C equals 2 pi 12. Times 12. Now we just figure out what that is. What is that? 24 pi?
24 pi. And again, since they gave us decimal answers on this, we could actually crunch the decimal answer out. And it's a word problem. 75.398 inches.
So
units are important.
Yeah, and we had to basically come up with a picture there. It was really helpful, and label the picture so that we would know how to fit everything
just
in there
about
together.
Every trig thing you're going to do requires a picture.
We also could have maybe used our arc length formulas somehow if we realized that our theta, since they didn't give us an actual piece of the circle, would have been 360 degrees or 2 pi in radians. Because, wait a second.
Did you say...
This is an r, not a pi.
Did you say 2 pi?
I said 2 pi.
Doesn't that make that the arc length?
It does as soon as I change this to an r like it was supposed to be. Oh, 2 pi r. Because I made this 2 pi.
So we did use arc length.
We did use arc length. We
Amazing.
just called it circumference.
Albert Juarez's truck. Oh boy, angular speed.
This is going to be great.
This is going to be awesome. He's got these wheels with 36 inches diameter. He's rolling on 36s.
Yes. If the wheels are rotating at 630 RPM, revolutions per minute, find the truck's speed in miles per hour. Now this is, if you're taking chemistry, this is dimensional analysis in disguise, but in math, we like to call it converting, because that's what it is.
Yeah, this is not that alchemy stuff that they teach down the hall.
If it helps you to think of it as dimensional analysis, by all means go ahead.
That's a potty word, quit saying it.
We're starting with RPM, that's what they gave us, 630 RPM, and we want to end up with the speed in miles per hour. So we are converting that. So 630, we got revolutions on top for 1 minute. We want to get to miles per hour. So I like to deal with the time first, because I think that's easier.
Yeah, definitely easier.
So
yes.
There's 60 minutes in 1 hour. Okay. Now we're done with the time because we canceled out minutes.
That was tough.
So now 1 revolution, the way this works is that 1 revolution is equal to the circumference of our circle. We have 36 inches in diameter, our arc length, okay? 36 inches in diameter, but our arc length usually uses radius, and we have the diameter.
Right.
So either we need to remember that circumference can be pi times diameter, or it can be 2 pi r. You know, like whichever.
Either way.
Like either way. Basically what we're going to end up with is 36 pi is our circumference. And that changes it to inches because our radius was in inches.
Right.
Right? Okay. Then we go from inches. There's 12 inches. Bless you. What was that? You blame that on the sun? And there's 5,280 feet in 1 mile. So we check and make sure, do we have all of our things, minute, we got hours,
okay.
rev, inch, feet.
Yep.
We've got mile. So we just, multiply the tops together, multiply the bottom,
630 times 60 times
36 pi.
36 pi. Make me some pie. Divided by
12 times 5,280.
12 times 5,280. I get 67.473.
And that's in miles per hour, which is mph, or some math teachers don't like that abbreviation. I don't know. Is that you? Do you have a problem with? Some people would rather you write it like that. I don't know. I just remember some math teacher at some point being like, miles per hour, blah, blah, blah. Never mind. Okay. It was a bad day for them. That's it. That's all we've got for 4.1.
Enjoy.
Yeah, good luck. Don't forget to put in the code word in Edmodo.
Code